Hello.
Who are we talking to?
I'm Veronica.
I'm Tyler.
And where are we?
We are in the optics lab at Scranton.
And I'm Declan. Now, we're looking at this beautiful torsional oscillator machine. Can you tell us what's going on here?
Sure. So this is a mechanical system that you use to study oscillations, and we're using it to learn more about natural frequencies.
Oh, okay. And I see, Tyler, can you tell me? I'm seeing yellow and blue lines. What's the yellow line?
The yellow line is a function of speed to time.
Oh, so the yellow line is the angle that this guy is making as a function of time. On the blue line is the speed that it's spinning as a function of time. Okay, and they're out of phase. What are these coils here? What are they for?
Those are Helmholtz coils. We can use a DC power supply to generate a current through there, and the magnets will be attracted to that magnetic field.
Those magnets there. Oh, so you can orient it, so you can twist it, and if you have an alternating current, you can make the magnet twist back and forth.
Yes.
So you can pump it. Okay. What can we learn about physics with this thing?
Well, we can use it to study kinematics by looking at the torque. We can also use it to study electromagnetics because the magnet will align itself with the magnetic field. We can also use this to study the way that light works too.
I just told you that because this is a beautiful model for an atom, and the way that because when you pump energy in these coils, this will receive energy at one particular frequency. The response of this to an incoming AC current here is exactly the same as the response to the electrons in glass. That's why glass is transparent. So this tells us actually why glass is transparent. It's really interesting. But hold on a second. This is a kind of a clunky oscilloscope. Let's see. Could you take this? Let's have a gander.
Do we want to show the...
Oh, yeah. Check this. Well, yeah, check this out. Oh, that's lovely. What's going on here?
So this is showing us each of these plots plotted against each other.
Oh. So, we have brakes. I'm going to actually make it go a little bit faster. Now look at the circle is bigger. So this is angle versus speed. And look, if I put in the brake, I put in these magnets, I can screw them in here, and we can put a damping force on this. And look here. Watch what happens when we have a damping force. We're losing energy. That is cool. Okay, good. Now we have an even better yoke over here. This is particularly useful. Could you point the camera at this lad?
Sure.
There we go. Okay. And now, this is an analog discovery USB oscilloscope. This is really handy. This is a super modern. And now, what we're going to do is, we're going to see, Tyler, can you we can do everything that old oscilloscope does. We're doing it here with this guy, and now you can see the same circle. We can control everything with software, and we can also freeze and write these files to spreadsheets, and it's really handy. Tyler, will you put on the brakes, and we'll see. Actually, hold on a second. Don't put on the brakes yet. Now, can you put on the brakes? Yep. And let's see what happens here. As Tyler slows it down, this thing it's going to center in. It's going to get smaller and smaller. Go to one spot. Go on. And there she is, getting smaller, and it'll eventually die off. So this is the power of this thing here. This brings everything up, and we control it with a computer, and we can do data analysis. So it's very good. Anyway, what do we say to Mr. Hayes?
Hey, Mr. Hayes from the Family Science Competition?
It's the same Mr. Hayes from the Family Science Competition.
Hi, that was really interesting to test out all the stuff for that competition. It's been very fun.
So this is the same Mr. Hayes, and he purchased this for us. So this is kind of cool. Okay, thanks very much, Mr. Hayes. See ya. Bye.
Bye.
No, isn't that grand?